welcome to my class on initial design, and I barely know how to run a computer, so please bear with me. I'd like to just thank Medtronic, first of all, for everything they've done in this program, for all their support of FIRST. They are amazing. I wouldn't be here. A lot of other volunteers wouldn't be here without FIRST. They are amazing, and they have supported our team since its inception. And I feel also a little humbled to be amongst Dean Kamen and Mr. Hess from Medtronic and a bunch of others here. This is an amazing group of people to be paired with. I'm going to be talking about initial design, not so much of a tech thing, but more of a how to work with your team, how to come up with ideas, how to talk to your team about ideas, and work with each other. Not so much a techie thing. At the end, if we can figure out how to do it, I want to put a link into chat. There's a little kind of a cute video of how to. It's called "How to Design a Stop Sign," and it's basically a design process gone horribly wrong, and it's a little comical, but it's pretty cute. So we're going to get started here. I hope my wife can be around here soon because I don't know what I'm doing. Okay, now we're going to go to the next thing. So we go to kickoff, and we watch a video. We watch the game reveal. We look at the game piece. We look at the rules. We look at the elements. And what I see too often, is a bunch of kids. A bunch of kids, first thing they do is they turn on all their computer screens. And what I want to back up a little bit and say, the computer is a tool. It's a wonderful tool, but it's only a tool. And the most important tool you're going to use, the computer is not going to think for you. What's going to be the most important tool is this tool that's right between your ears here. And that's what I want people to start using. So when you initially use a computer, you initially find your game. Think about your game. Where are we going to start? What do we do first? What I want you to do is take out your tape measure. Grab this game piece. Get to know this game piece. This is a game piece from a few years ago. What does this thing look like? Is it heavy? Is it light? Does it bounce? Does it roll? Is it slippery? Is it sticky? Throw it around. Play catch with it. Bounce it off the floor. Throw it out the window. Whatever. Learn that game piece. The kids that should have the computer screens on are the ones that are looking up the rules and looking up the rules and looking up the robot rules and the game rules. Other than that, like I say, take out a tape measure. Now go to the wall and mark the goals. Let's say there's a low goal and a high goal. Okay, mark those things out with tape. Put get out your step ladder. Put out a high goal. So now you've got a concept of what this goal is. Here's the game piece. I'm playing with it. What is this goal? What do I have to do with this game piece? Look in the rules and say how many game pieces are you allowed to carry on your robot? What do you have to do with this thing? If you carry 5 game pieces, maybe what do the rules say? Maybe you can reach out, say, 17 inches from your frame. Okay, so what does that look like? Take your old robot, set it on the floor, and get a stick or something that's 17 inches and go, okay, what does that look like? Where can I grab this thing? Where can I grab it on the inside? Can I grab it on the top? Can I grab it on the bottom? What does that look like? How am I going to carry 5 pieces on this robot? What is that all going to look like? So just get a concept. Before you turn all your screens on, get a physical concept of what your screen is going to look like, or what your game is going to look like. What's your get some basic parameters figured out. before you start doing CAD and turning a bunch of fancy equipment on. Okay. Next slide. We're going to move on here. Where do we get ideas for this stuff? And initially, we're going to get ideas from. There's a bunch of sources out there. There's teams called Robot in 3 Days. There's robotics teams. They're kind of informal teams. They're usually first kids that have grown up through the program and now they're in college. And they will stay up for 3 days and drink a lot of coffee, and they'll build a robot in 3 days, and they'll show the whole thing. A lot of times they're live streaming their whole process, and you can tune into those things. There's teams all over the country. They don't really compete. They just kind of show the concept and kind of help others. You can tune into that and get some ideas. Other teams will put ideas out. How do we do these things? They'll do some demo stuff, prototype stuff, and they'll show some of their prototype. Maybe they have a really cool shooter or pickup mechanism. During the early days of the build season, they will put together some of their ideas and put them online. Sometimes you can look at old games, you can past games, you can look at, you might have mentors that remember, oh, you know what, this game is really similar to the 2017 game, or this is real similar to the 2014 game, or whatever it is, and you can look back and see some of those games and look at some of the competitions that are online and see what some of the best teams did and gain some ideas from that. Having said all that, that's stealing ideas from other teams, from other people. One thing I like to do with kids is, hey, we're kind of stuck for an idea. Throw all the kids in the car. Hey, let's go to Menards. And I take the kids and just send them out to Menards, just run around and look at things. Pretty soon they look at, hey, maybe we can use this thing for this thing, or maybe we can use this for a pickup mechanism, or we can use this for something else. And they'll find things like that. So that's a good way to do things. That's the beautiful thing. I love to see teams come up with their own ideas like that. Come up with creative solutions to these things. That's what I like about FIRST. To go here, this is a game piece that we had a few years ago, and this thing was heavy, and it was weird. It was weird shape. It was hard to pick up. It was hard to floor lift. A lot of people wanted to pick this thing up off the floor. A lot of teams tried and failed to figure out how to pick this thing up off the floor. And as an inspector, I get kind of VIP tour of all the robots. And one thing I found was there was a team that they must have went to a pet store, and they found like a dog chew toy, this kind of rubbery thing, and it had little bulbous ends. They had a couple of these things, and they found this dog chew toy that was just perfect for grabbing this piece on the outside, and they could pick it up just perfectly. And that's just a great creative solution to a problem that they didn't get from anybody else. They just walked around the store and looked at things. Anyway, moving on. Should we be using CAD? Shakespeare once said, to CAD or not to CAD. I think Shakespeare said that, maybe it was someone else. But anyway, my suggestion here is, do you already know how to do CAD? If you already know it, it's a great tool. By all means, go for it. But at the same token, don't use build season to learn CAD if you don't already know it, because you don't have time for that. Off season is a great time to learn CAD. Summertime, if you got a few kids that want to learn it, that's great. But don't hold up your team and don't have your whole design locked up in the head of 1 or 2 kids because your team has to wait for that. You don't have 3 weeks for your first CAD drawings to come out before your team gets started. You've got to get started right away. So if you're going to do it, don't make sure you're not holding up your team. Making sure your team can keep moving forward and doing its thing. So don't hold up your team. One thing you can do is just CAD one component. If you're going to do CAD during build season, maybe you got a really cool pickup mechanism or something. You can show that to the judges, make a nice CAD drawing of that, and maybe you win some engineering work. Anyway, moving on. Brainstorming. Everyone needs to participate. Everyone gets to participate in brainstorming, and that brainstorming, you throw up your ideas, everybody looks at it, everybody gets an opportunity to participate. When you brainstorm, you throw up these ideas, and everybody gets a chance to participate. Everybody gets listened to. You throw up all these ideas, whether or not they make sense or not. They could be crazy ideas, but throw out all the ideas. Then, from there, I think I'd like to build a robot that weighs 500 pounds, small diesel engine, has about 6 batteries on it, and a flamethrower. Okay, guess what? All those things are illegal. Okay, so we can't do that. Now, this is an idea that I stole from Ryan Swanson called thinking inside the box. So whenever you do something, you can't just, it's not the sky's the limit. You can't, whenever you work for somebody, they don't tell you, oh my goodness, you can just do whatever you want, take as much time as you want, cost is no option, just do whatever you want. That's just not reality. That's not going to happen. So what do? We're going to, we have to work within limitations. Then real life, we work through limitations. So we have to first follow the rules. What do the rules say? What are you allowed to do? How big, how heavy can you be? Cost. There are rules about how much money you can spend on your robot. So cost, there are cost rules in the rules, but your team might have their own cost rules. Your team might be like, okay, yes, you can spend $5,000 on your robot, like the rules say, but we ain't got $5,000. So you might have additional restrictions because of the amount of money your team has. And I don't want anybody to run around with your tail between your legs and say, oh, we can't build a good robot like that team over there because they got all kinds of money. I've seen the most creative, innovative things done by low budget teams building on a shoestring budget, and they really use their, I admire the teams that use their noodle instead of their checkbook to build something really neat. There's time issues. How much time are you spending on your robot? Are you meeting once a week? Are you meeting 5 times a week? That's going to determine how fancy of a robot you can build. What is the age of your team? Are you a rookie team? Are you been doing this for 5, 6 years? Are you a veteran team? And how old are your kids on your team? Did all your seniors graduate? And you've got a bunch of 9th graders now, so the experience level of your team is gonna determine how fancy or how complex a robot you're gonna be able to make. How many mentors do you have? what's your shop facility like? Do you have a shop that you can use, or are you building your robot in your school's basement, or in your school's hallway? Some teams have really nice shop availability, and some don't. How many mentors do you have? Do you have any mentors at all? Do you have lots of mentors? Maybe you have lots of mentors, but they're all English majors and poetry majors and art history majors. That's going to be an issue. So if you have mentors that are doing computer and sensor things and programming, that's gonna determine a lot of times what you're going to be able to build. Now, everybody builds a robot. Everybody gets to listen to their ideas. Everybody gets their input. Then we need to get to a point where we narrow down to one idea. You can't utilize everybody's idea. That's just not realistic. That's just not going to work. So guess what? Not everybody's going to get their way. What if you don't get your way? Are you the team leadership? However your team decides to make decisions, your team leadership has decided we're going to go this direction. What if you said, I really wanted to do this, but my team went the other way? What's going to happen? Are you going to get mad? Are you going to quit? Are you going to not participate? They didn't listen to me. I'm not going to participate. There's a point of maturity here that has to happen. You have to participate in your team. You have to do your part. Because the whole team has to build one robot, so you're gonna have one concept basically. Having said that, you don't want to allow just one or two people to own the design and build. You don't want Tommy and Billy and Billy's dad to take off with the whole design, the whole build thing, and not listen to anybody and just take off. That can be poison to a team. I've seen that before. Whether it's real or imagined, you want to make sure that everybody's a part of it, everybody's participating, and you don't just have one person that's taking over, one or two people that's taking over. Everybody buys into this robot. Everybody on your team, whatever your team is, whatever your role on the team is, whether you're the team captain, whether you're a driver, whatever it is that you do on your team, you have to be, whether you're on the marketing team, whether you're somebody that sits and stands as a scouting, it's everybody's robot. Everybody buys into it. Everybody participates in their own way on the team, whether or not all of their ideas got incorporated or not. So this is, it's crucial that when you cut yourself, you should be bleeding your team's colors. When your team wins an award, it's everybody's award. It's not just Tommy and Billy and Billy's dad that won the award. It's everybody's. So anyway, moving on here. Simple versus complex. Do we make a simple robot? Do we make a complex robot? If you make a simple robot, it's easier to build. It takes less time. It's going to be more. It's going to be less complicated. You're going to have less breakdowns. Where a complex robot's going to have more capabilities, but it's more difficult. It's going to be costlier. So where are you going to fall on the spectrum? What does your team know how to do? I think it's important to make a priority list. So talk to your team and say, okay, first of all, we want to do this. Where are you gonna fit in to an alliance? Are you gonna be the team that does all the scoring and be the big the big kid on the block as far as your alliance goes? Or are you gonna have more of a support role? Are you going to have build a defensive robot, or maybe build a robot that just works with other robots? Maybe we'll build a robot that other robots can climb on top of and do whatever it is.
secondary that, thirdly that, whatever. You want to look at the game rules of what are the rules say, what does the game, where do the points fall? What does the end game do for you? And how important is the end game? Sometimes the end game, the rules or the points are such that the end game, you're going to win or lose the game by the end game. Sometimes the end game doesn't make that much difference. It just depends on the rules. There's a concept called a God box. And so some teams are able to build, let me back up a little bit. It's almost impossible to build a robot that does every aspect of the game and does it all well. And that's the concept of the God box. People talk about that. You're going to build a God box. That's the bot that does everything well. And usually when you try to do everything, you do everything kind of poorly. And you just kind of come in the middle of the pack and you just kind of whatever. So it's very difficult. There's maybe a handful of teams in the state that can build this God. If you already know who you are if you're doing that. So what should you do? Where should you fall in the simple versus complex scale? I would say challenge your team. Your team every year should be growing, improving. What did you do last year? Okay, we built a forklift last year, but we had some technical problems with it, but we've kind of learned from that. Well, maybe you should build a forklift again this year, but you've learned what not to do. But you should always be growing and improving. You built a real simple robot last year. Maybe this year you should try to make it more complex. Do more things, more capabilities. Maybe last year you built a robot that was so complex that you bit off way more than you can chew, and you did really poorly. You just suffered with technical problems all the time. Okay, maybe this year you may want to scale it back a little bit, make something a little simpler, stick to some basics, do a good thing. What I would say is find your comfort zone. Then push out of it. And what I mean by that is I like to work with kids and kind of learn what they know, where their comfort zone is, and then push them a little bit out of it. Push them 10, 15% out of their comfort zone. So I'll tell you right now, I'm way out of my comfort zone trying to do this Zoom thing. So this is a challenge for me. But pushing out of your comfort zone is going to make you grow. It's going to force you to grow. You're going to be a little uncomfortable, but that's what growing and learning is all about. So we want to always be improving. So I'm going to move on here. The think-do ratio. Now, this is one of my this is my idea. Something I've kind of invented. There are people who are thinkers, like this guy. He's a thinker, okay? And he's thinking all the time. He's thinking about a lot of things. And this is a doer. This is Wile E. Coyote. He's one of my favorite actors. I spent a lot of time growing up watching the Coyote on Saturday mornings, trying to catch the Roadrunner, thinking of all kinds of ideas, trying to catch this Roadrunner. And this is a man of action. We can emulate. We can really admire a lot from the Coyote. He's very determined. He's an action person. But the thing about the Coyote is he doesn't always think things through completely first. So Mr. Coyote, he tends to fall off a lot of cliffs. Gets hit by an occasional freight train. Sometimes he gets an anvil on the head. Don't know if he ever actually caught the Roadrunner, but he's really trying hard now. So he's a doer. We like the Coyote, except we're going to go back to the thinker, and we want to think things through before we do things. So if you build a robot without thinking it through first, it's not going to work very well. Your components aren't going to work well together. You're going to run out of space. you're going to be too heavy, you have a lot of issues. So you want to be a thinker and a doer. Now, I worked with a team a few years ago, and they were in trouble. We got a call, help this team. They're running out of time. They need some help, and they're like 2 weeks out of build. They're 2 weeks left to build, and they just can't figure it out. They don't have any mentors. So I show up. Okay, here I am. What are we doing? What's the plan here? I'm going to help you. Every one of those kids was sitting in front of their computer screen. Okay. And they're thinking. They show up. Okay, what's the plan? They go, well, we're thinking about this, and we're thinking about that, and we'd like to have this, we'd like to have that, and we'd like to incorporate this thing. And I'd say, wait, stop! You're doing too much thinking, not enough doing. You spent too much time thinking. Has anybody cut any metal yet? You need to start doing. So the ideal thing we want to do here is we want to think. We want to think things through, but then we also need to do. You need to think about how much time you spend thinking versus how much time you spend doing. And you need to think about all the time what kind of a ratio we got going on with that. So with that, this is the end of my session. I want to have, can we somehow put up